The next lesson that we're moving to is lesson number 4. And in lesson number 4, we are looking at electrochemical cells. Okay, we have already dealt with this as well in natural science term 3. An electrochemical cell is a component consisting of two metal electrodes immersed in an electrolyte, which is a chemical conducting solution. We've done this. A positive electrode is the cathode of copper, and the negative electrode is the anode of zinc. We've done this on the electrolysis process. The commercial cell, which is the torch cell, converts chemical energy into electrical energy. Once the circuit is closed, a chemical reaction causes the current to flow. The chemical reaction occurs in the electrolyte, which is a liquid or paste in the closed container, connecting the positive electrode, which is the cathode, and the negative electrode, which is the anode. The electrolyte carries the current between the two electrodes. This reaction causes a positive charge on one side of the cell and a negative charge on the other side. If the chemical reaction stops, the cell is flat. Okay, for example, if we run out of the electrolyte, then the cell is flat and there will be zero voltage. Okay, and I think in one of the question paper it was asked what happened if the electrolyte dries up. Okay, and we look at batteries now. We've dealt with the chemical cell. A battery consists of two or more cells, we know that by now, connected to one another. Cells should be connected correctly to ensure that the current flows from the cell to the output device, which is the lamp or light bulb or any other output device. The current will not flow if the connection is made incorrectly. For example, the positive terminal must be connected to the negative terminal. If the circuit is incomplete, the current must flow from positive terminal to the negative terminal without being interrupted. And a current will not flow if there is a short circuit. So these are the three things that will make current not to flow: if the connection is incorrectly made, if the circuit is incomplete, and if there is a short circuit. Now we look at the cells and lamps in series, or light bulbs in series. We have already dealt with this. We have dealt with this already in natural science. Okay, in a series battery circuit, the positive terminal of one cell is connected to the negative terminal of the next cell, so that the electric current flows through all the components. So this is the positive terminal, this is the negative terminal, but this negative terminal is connected to the positive terminal of the next cell. If two lamps are connected in series, the same current will flow through both lamps. We have done this, we even done the practical. So we have the cells that are connected in series, and we have the light bulbs that are connected in series, and the same current will flow. What are the advantages of a series circuit? More cells can be added to increase their output. So if we connect more cells in series, the output will increase, which means the bulbs will shine brighter. Okay, and it will result in the stronger current. Okay, let me move up a bit to the next page, 184 in your textbook. Now we look at the disadvantages of a series circuit. Adding more components to the circuit will increase the resistance, and the lamps will not shine as brightly. So if we add more output devices, not more batteries. If we add more output devices, then the lamps will not shine brightly. So which means if we add more lights, if one component fail, all the other components will also stop. So we have done this in the practical. If one bulb fails, then there will be no current flowing. When one component fails, the circuit will be interrupted and prevent the current from flowing. Okay, now let's look at the cells in parallel. Okay, in the parallel battery circuit, the positive terminals of cells are connected to each other and the negative terminals of cells are connected to each other. Okay, so this is a cell, this positive is connected to that, and this negative is connected to that negative. Okay, so you see positive, positive, negative, negative, or sorry, positive, positive, negative, connected to negative, and the current flows from the positive terminal. If lamps are connected in parallel, each lamp is wired to the battery on its own separate loop. Remember, we talked about the pads, different parts. Okay, we said current will have different parts when we did this experiment in natural science. If lamps are connected in parallel, each lamp is wired to the battery on its own separate path. Each lamp shines separately from others. So if you look, the current will flow from here all the way to this one and go the way out. Okay, and if you look the other one, the current will flow from here all the way to this one and go to the other side. Okay, so there are different parts on the circuit. So what are the advantages of bulbs connected in parallel? Advantages of bulbs in parallel: all lamps shine equally brightly. All lamps and appliances in our homes are connected in parallel so that they may be operated independently. So if one fails, the other ones in the other rooms will still work. Advantages of a parallel circuit: a short circuit in one of the loops will cause the affected appliance to stop working while the other appliance will continue to function. The lamps connected in parallel will have the same current flowing through each one. This means that all the lamps will have the same voltage and will shine equally brightly. Okay. Then we move to lesson number 26 on a generation of electricity. How is electricity generated? And we look at thermal power stations. Okay, a turbine, this is the coal power stations. A turbine rotates to provide mechanical energy that a generator needs to generate electrical energy. Okay, so they say a turbine rotates to provide mechanical energy that a generator needs to generate electrical energy. Okay, so generator generate electrical energy and turbine provide mechanical energy. This is very important. You will see when we get to the diagram. Different types of fuels are used to rotate turbine. For example, we can use coal, we can use the water, and we can use nuclear to rotate the turbine. Boiling water creates steam in a coal power station. Boiling water creates steam. The pressurized steam then rotates a turbine. The thermal power station need fuel to generate heat. In South Africa, thermal power station use coal or nuclear energy to produce electricity. The majority of South African power stations uses coal to generate electricity. Now let's look at coal energy. In a thermal power station, coal is burnt in a furnace to generate heat. This furnace is called a boiler. So coal is burnt in a boiler or the furnace to generate heat. This heats the water inside the boiler. There it is. It heats the water inside the boiler to produce steam. The steam rotates a turbine which drives the generator shaft to generate electricity. So this paragraph is very important because this is how electricity is generated. Okay, so we take coal, we burn it in a furnace, and this heat that comes from the hole heats up the water inside the boiler to produce steam. That steam rotates the turbine, which the turbine now will drive the generator shaft, and the generator shaft will generate electricity. After the steam passes through the steam turbine, it passes to a condenser where a third water cycle cools down so that it condenses back to water. So which means the steam is cooled down to form water, and then that water goes back again to start with the process of being heated again. So this paragraph is very important. Please, this is how electricity is generated. Okay, so let's go to the next page, page 189. Now we will be able to see the process. So we have the coal coming from the coal chutes. Okay, this here you will have mines, and the coal will come with something called a conveyor belt, will go to the chute, and the coal will go to the mills. It will be crushed into powder. Okay, crushed into powder. Then after that coal is crushed into powder, it will go inside the boiler, and then inside the boiler this coal will be litten up. They will combine coal and fuel and also ignite that to form fire. Then once fire is formed, there is a boiler tubes. Okay, this is a boiler where there is fire, but inside there are boiler tubes. So this fire will heat the water inside these boiler tubes. Okay, once this water will be heated in such a way that it is converted to steam, and this steam now will be pressurized and it will move to the turbine. Okay, so when it comes here to the turbine, this steam will turn the turbine. That is mechanical energy. When the turbine turns, we have mechanical energy here. Okay, so it will turn the turbine will rotate, but you can see that the turbine is connected through the shaft, is connected to the generator. Okay, now once the turbine turns, the generator will also turn. Then the generator will turn. When generator turns on the other side, now it will be able to generate electricity, and the electricity will go to the transformers, and it will be transformed from one line until it gets to our houses. Once this steam, okay, so we are done. We have electricity now. Okay, so it starts with the coal from the mine. It comes with a conveyor belt. It goes to the coal chutes. We call this coal chutes. And then here, this we call them the mills. These mills, they crush the coal into powder, and this powdered coal comes here into the boiler. It is mixed with fuel. It can be oil and diesel, and we ignite that. When we ignite that, the fire starts in the boiler. This whole thing is the boiler, and inside the boiler we've got boiler tubes that are running, and this fire will heat up the boiler tubes, and the water that is inside this boiler tubes will be hot until it is converted into steam. The steam will be pressurized, will be put through a pipe. It will be under pressure, and it will be released here when it gets to the turbine, and it will turn the turbine. Okay, and the turbine is connected to the generator, and the generator will turn as well, and on the side will generate electricity. Then the electricity will go to the transformers and transmissions lines. Then it can go wherever. Okay, now this steam, remember we said it turns it's hot, it turns the turbine, but once it is cold, it condenses to become water. Okay, then it comes here to the condenser, and it comes back as water now, because the steam is condensed. Now it is water. Then it comes back and it goes back to the tubes again. So we use recycled water, so we don't lose the water. And then the other water that is still hot as steam, it will go to the what do you call these things, the cooling tower. Okay, you see, steam will go to the cooling tower, and the cooling tower condensation will take place still. Okay, and normally you will see something like smoke comes out of the cooling tower. People, they think it's smoke, but it's not smoke, it is steam. This steam is being condensed down again. You see, from being hot steam, it becomes water again, and it is collected at the reservoir, and some of it goes back to the as cold water, and it goes back to the boiler. So that's how electricity is generated. So please, this picture is very important as well. Very, very important to understand generation, how we generate electricity in the country. I will repeat again quickly and short, and we are done. Coal from the mine comes with a conveyor belt to the coal chutes or coal bunkers. It gets to the mills or the crushers. They crush the coal into fine powder. This coal enters the boiler and it is mixed with fuel, and we ignite it to start the fire. This fire hits the boiler tubes in the boiler, and this water is converted into steam. That steam is taken out to the turbine. It turns the turbine. The turbine is connected to the generator. The turbine turns the generator, and the generator generates electricity, and electricity goes to the transformer, and after that the transmission line, then to our houses and towns and everything. So in the turbine there's mechanical energy, and in the generator mechanical energy is converted into electrical energy. Okay, so that is the electricity generation process. So now let's look at the advantages of coal power stations using coal, or sorry, thermal power stations using coal. Thermal power stations are effective and supply large amounts of energy, and coal is cheap. Thermal power station can be built nearly anywhere and are cheaper than other types of power stations. The disadvantages of thermal power stations using coal is that thermal power stations require large quantities of water. As you have seen, we use water a lot in the boiler, which is a scarce commodity or resource. Gases and smoke are released. Okay, the gas, you saw it in the cooling tower, and the smoke, you didn't see it, but it comes out on a smokestack, are released when coal is burnt, which cause air pollution. And also, because we use coal mining pollutes the environment, and coal must also be transported to the power station either via the conveyor belt or the trucks. In the olden days, they even used to use the trains. Coal ash must be disposed. Coal ash must be disposed of safely to prevent air pollution. And let's look at nuclear energy, because we also have nuclear power stations. Nuclear power stations use uranium as fuel. South Africa is one of the top uranium producing countries in the world. 1 kilogram of uranium supplies the same amount of energy as 3 million kilograms of coal. Uranium is one of the elements. You remember we did a periodic table, so it's one of the elements in the periodic table. Even though nuclear power stations do not cause air pollution, the waste products created during the nuclear reaction are extremely toxic and harmful to the environment. Disposal of nuclear waste needs to be exceptionally carefully managed, and this is very expensive. Uranium atoms are split during the process called nuclear fission, which takes place in the reactor core of a nuclear power station. Now they are explaining how does the nuclear power station works. We will see it at the bottom. Heat energy is released during the process. The high temperature converts water in the generators to steam, and the steam drives the turbine that rotates the generator shaft to generate electricity. Okay, so the only difference with the coal and the nuclear power station is that with the coal, we use a coal to heat up water, and with the what do you call it, with the nuclear, we use uranium to heat up the water. And they say after the steam passes through the steam turbine, it passes to a condenser where a third water cycle cools down so that it condenses back to water. So let's look at the cycle quickly. You see here we have the reactor vessel. Okay, instead of having coal in the coal-fired power station, then we have this uranium that it's split during that process that they call, what is that process called quickly? It's called nuclear fission. Okay, so and when it splits, it heats up the water into steam, and the steam turns the turbine also turns the generator, and generator generate electricity. Same process, water is condensed back to the reactor, and from the cooling tower, the steam that escaped to the cooling tower also condenses back and comes back to the boiler. Some of the water goes to the reservoir. Okay, so it's similar. The only difference is the heating up of water. We use uranium. Okay, and then in the coal fired, we use coal to heat up the water. Otherwise, the process becomes the same. So in South Africa, we only have one nuclear power station in Cape Town. It's called the Koeberg Power Station. Okay, now let's look at the advantages. The advantages of a nuclear power stations: they are effective, supplying large amounts of energy. Uranium is a fuel type that lasts a long time, and they can be built nearly anywhere. And let's see at the disadvantages of nuclear power station. They require large quantities of water, which is a scarce resource like coal power station. But a depleted uranium, which is the uranium that has been used, must be stored in specific ways to prevent pollution. And mining uranium is dangerous, and enriching it is complicated process. Therefore, nuclear energy operation requires specialized personnel and equipment. And the third type of the electricity generation is hydroelectric power station. Hydro means water, so it's water electric power stations. So how does it work? This one, so we have a demo. Okay, let's go for the explanation first, and then we can go to the diagram. I will try and minimize this. Okay, so hydroelectricity uses the energy of running water to generate electrical energy. Hydroelectric power are built near running water, which means near dams. Most hydroelectric power stations are located at large dams, rivers, or waterfalls. The flow of the water from the dam can be controlled by opening and closing the sluice. So this is the flow of water, this is the dam wall, and there's a sluice. A sluice is like a gate, so they can control this sluice. And the dam wall also create high water level, and this increases the pressure in the pipe that deliver the water into the turbine. So what happens here is that when this sluice is open, water flow at a very high speed because it is at high level, and the pressure here, it flows and here, and it turns the turbine. So the turbine here on the hydroelectric power station is turned by water. Once the turbine turns, it is still connected to the generator, and the generator will generate electricity. Electricity will go to the transformer and the transmission line. So the key thing, or the key difference, is how the turbine is turned. With the coal, it is turned through steam, okay, that is fired by coal. In nuclear, it is turned by steam that is fired by nuclear or uranium. And then in hydroelectric electric power station, the turbine is turned by water under pressure. Okay, so now you understand the three different ways of generating electricity that we use in South Africa. Okay, and advantages of hydroelectric power station: electricity can be generated as soon as the dam is built. Electricity generation can be controlled by opening and closing the sluices, which are those gates. There is no pollution during power generating process, and hydroelectric power is a form of renewable energy. And the disadvantages of hydroelectric power stations is that the dams required for hydroelectric power generation are expensive to build, and they are not effective when there are droughts. Okay, so we are dependent on water and the rainfall. Now let's look what other alternative energy sources do we have. They say fossil fuels need to be replaced by alternative energy sources because South Africa has limited water resources. For example, it is estimated that the country's coal reserve will only last until the middle of the 21st century. When coal burns, it produces carbon dioxide, which causes health and environmental problems. And the waste products from nuclear power station are highly toxic and cannot simply be dumped without proper management. Okay, so fossil fuels needs to be replaced by alternative energy sources because of this reason. So you need to know this reason: because of limited water resources, as well limited coal reserves, and the coal produces carbon dioxide, which is not good to our health and environment. And the waste product from nuclear must be treated properly. Okay, now what are alternative solutions that we have? We have wind turbines. So wind power is the conversion of wind energy to electrical energy. When the wind blows, it rotates the turbine blades. The blades attached to the hub, which is mounted to the shaft. Then the gearbox is also connected to the shaft, which turns the generator and produce electricity. Okay, so these are our wind turbines. And then the advantages of wind turbines: they do not generate air, water, or environmental pollution. That is good, no pollution at all. They produce a source of renewable energy, and wind is free and readily available at right locations, not any location. And what are the disadvantages of wind turbines? No electricity is produced in the absence of wind. So if there's no wind, there's no electricity. Wind turbines are expensive to install, and wind turbines produce noise pollution. And the other alternative is the solar energy. The solar energy is the energy from the sun that is captured by solar panels and stored in batteries. The stored energy may be used to power household geysers and lights. An inverter converts the direct current from the batteries to alternating current that can be used. Okay, so the alternates that we have learned about so far, it's the wind power and the solar power. And the generation power stations are coal power stations, nuclear power stations, and what the hydroelectric power stations.